Worksheet 8 for Academic Decathlon 2024-25 in the subject of mathematics. And we're sticking with linear equations. Well, actually, they're not even linear. Some of these are not linear. We're dealing with equations and also functions. So here we have actually formulas where we have the perimeter formula, and we're going to isolate for W. It's currently isolated for P, but we're going to isolate for another variable within the formula. So we're going to isolate W. We're going to try to get W by itself, and there are two things happening to it. It's being multiplied by 2, and it's being added to 2L. So what do we get rid of first? We get rid of things being added and subtracted. So we'll subtract 2L from both sides. That can give us P minus 2L equals 2W. Now there's lots of people, L comes before P. You know, the order of this, when it's formulas, it gets a little bit crazier. Now we have to get rid of the 2 being multiplied. We're going to divide by 2. And again, we have some discrepancies. Some people will allow you to have this as your answer. And then some people will want that to be under each of them, right? That 2 is under each of them, so you would have P over 2 minus 2L over 2, which could be simplified. So some people will leave it like this. That was a horrible circle. Some people will leave it like this. And then some people will simplify this to P minus 2, P over 2 minus the 2's cancel, L equals W. And then some people will have this equation. All right, so depends on what your teacher accepts. They're the same equations. Both are simplified. Both should be seen as being able to leave as an answer. We're going to isolate R. We have to notice that R is being cubed, so that's kind of a little hard and crazy. That's a little bit different. 4/3 pi R cubed. So we can do it in two ways. We can get rid of the 4/3 first by multiplying by the reciprocal, because everything is being multiplied. So the reciprocal of 4/3 is 3/4, and we get 3v over 4 equals pi R cubed. And now we're not going to divide by pi, we're going to actually multiply by 1 over pi. Dividing by pi would create this big mess, and that gives us 3v over 4 pi equals R cubed. All right, now we have to get rid of this cube because we want to isolate for R. R is being cubed, so we're going to have to take the cube root. We have to put a 3 in there, and the cube root, and we're going to take the cube root of 3v over 4 pi and R cubed. So those cancel. And this, now we can't have a radical in the denominator. So I'm going to do this separately. I'm going to separate those. I'm going to make it big enough to see 3v. The cube root of 3 is not 1. That's not simplified. And then we have the cube root of 4 pi equals R. These cancel. Cube root, cube, cancel, and you're left with R. But we can't have this radical in the denominator. So we're going to have to rationalize it. Let's make that v a little bit bigger. And this is where it gets technical. The cube root of 4 pi. So what gets rid of a cube root of 4 pi? Well, okay, how many 4? So we need the cube root of, so what base for 8? 8 is a cube root, so 2 pi squared. So the cube root of 2 pi squared will get rid of it. Because you'll see, what do we get here if we multiply those two? If we multiply those two, we get the cube root of 8 pi cubed. Now, 8 is a perfect cube. Pi cubed is a perfect cube, so that would be simplified to 2 pi. So this is called rationalizing. It's a little bit more complex when it's not 2. Typically, when it's 2, the square root, we just multiply by its identical value. All right, now let's deal with this. This gives us the cube root of outside out. This is 2 and 3. That's 6 pi squared v. Ooh, and that's the cube root. Cube root of 6 pi squared v. Now that will be interesting to see if that is the answer. Let's see what... Oh, I don't think I put the answer. Let's see the answer. That will be... What? Oh, no. Warm up. That's only a warm up. No, that is wrong. That is so wrong. You can't have that. You can't have a radical in the denominator. That is so wrong. Bad answer. Bad answer, academic decathlon. You have to rationalize. So you see that we had that. We had it over here, right? That would have equaled right here the cube root of 3v over 4 pi. But that is not acceptable. You have to rationalize. So my answer is correct. Let's solve for b. So this is much easier. And I'm going to do this because I want to get b by itself. I got to get rid of h. H is in the numerator. So if I multiply by h in the denominator, I got to get rid of this 2. The 2 is in the denominator, so I put it in the numerator. And 1 is in the numerator. Gets rid of it is a 1 in the denominator. That's not going to do anything. So that is the easier way. 2a over h equals b. That's the fast and quick way of doing it. We had to get rid of both of these. So the reciprocal of 1/2 is 2. Reciprocal of h is 1 over h. And we did it in one fell swoop. I like, actually, I don't like this. This is not as hard. I'd like it to be one of the interior ones. But we want to get h by itself. So we have to get rid of this and this. This is Chewbacca, so it's holding it all together. So b sub 1 plus b sub 2 times h. So the reciprocal, actually, let's move you down here. The reciprocal is going to be, well, the 2 in the numerator, and then the quantity of b sub 1 plus b sub 2. We don't need parentheses because there's a vinculum here. So we're going to multiply it by 2 over b sub 1 plus b sub 2. And my answer ends up being 2a over b sub 1 plus b sub 2 equals h. That's good. If you can do it that fast and see it, that's the important thing. That's the level you want to get to isolating variables. All right, now we jump to functions and inverse functions. So inverse functions, you see this to the -1, that's a notation for inverse. Inverse just reverses these two values and solves for the other one. So they teach you, they say, hey, flip those. Go x equals 2/3 y plus 7, and now solve for y. So we're going to subtract 7 first. We get x minus 7 equals 2/3 y. We'll multiply by the reciprocal, 3/2. Multiply by the reciprocal, 3/2. And we would get something. There's a couple of answers you can do. You get 3x minus 21 over 2. So we distribute 3 times x. 3 times 7, -7, and then we have the denominator there because they'd have the same denominators. So you can have that. You can have 3x over 2 minus 21 over 2 equals y, or f of, so this is our f of -1. So you can have 3x minus 21 over 2 is our f of f to the -1 of x. Yeah, it's the inverse. Look at that. All right, let's switch it. So we get x equals the cube root of y plus 1. Okay, what's going to get rid of a cube root is a cube. So we cube both sides. we get x to the third equals y plus 1. Let's subtract 1. And we get x to the third minus 1 equals y. So my inverse function would be x to the third minus 1. This is really good because this is algebra 2 and pre-calc and calc is finding inverse functions, derivatives, all these fun things. So we're going to flip them. We're going to reverse the variables. Squared plus 6, and now we're going to isolate. So we'll subtract 6 first. You get x minus 6 equals negative 3 times the quantity y plus 4 squared. Let's divide by negative 3. Divide by negative 3. I'm going to write negative 1/3 x plus 2. That negative 3 is under both of those. Equals the quantity y plus 4 squared. Now we have to take the square root of both sides. Negative 1, sorry. We have to take the square root of both sides. Let's stick to red. And we're going to do negative 1/3 x plus 2. And we have quantity y plus 4 squared. And those cancel. So you're left with the square root of negative 1/3 x plus 2 equals y plus 4. Let's subtract 4 from both sides. And we get the square root of, let's do negative x over 3 plus 2 minus 4, that's on the outside of it, equals y. And that would be the inverse. Square root of x, negative x over 3 plus 2 minus 4. That would be, we don't need that. We don't need the equals because we know, and that should be our answer. You want to check it? I want to check it. Where's my answer key again? Answer key? No, that's the worksheet. Where's my answer key? I'm just inquisitive. Negative x, yes, plus 2 minus 4. And that could be either place. That's good. All right, we like that. We like that we were correct. All right, this one's a whole lot easier. So we have x equals negative 3/5 y minus 30. Wow, they really get easy real quick. And they are completely different problems. This is super easy. The other one was very hard. We're going to multiply by negative 5/3. Negative 5/3. And we get negative 5/3 x minus 50 equals y. So negative 5/3 x minus 50. Because we're going to distribute that. That gets this. 3 in the denominator cancels with that. 10. Negative 5 times 10 is negative 50. Okay, now in these problems, they want to know, hey, what's happening going from this function, we'll call this the parent function, to this function. So what types of changes are happening to it? So there's multiple things. This is talking about something, this is talking about something, and this talks about something. So we're going to go and see, watch what happens. We're going to go over to Desmos real quick. And we're going to put in the parent function. That parent function is x squared. X squared. So if we say f of x equals x squared. So we have a regular parabola. Okay. And what happens to this? G of x equals 2 times x plus 5 quantity squared minus 3. So what happens to the parabola? Well, we always want to look at where the vertex is 0, 0, and now the new vertex is negative 5, negative 3. So clearly it shifted left and down. So how do we know that? And it got more narrow. okay, because it's going to be multiplied by 2. That is, so what do each of these? Well, you know, this is always going to be my y-axis. This is always going to be my y, so that's my y-axis. That always tells me whether I'm going up or down. So I went down 3. So one of the changes is down 3. And now here is, okay, it's plus 5, but we saw that it went left. So inside the parentheses is going to be on my x-axis. And it's going to be opposite of what it says. Opposite. Okay, so if it's plus 5, we know it's moving to the left 5. And now this number out here is either well, we don't want to call it a shrink or expand, but it does change its narrowness. It's going to make it steeper. I think it's called a vertical. Let's look at the answer key. I think it's called a vertical shift. What is it? Taller by 2, left by 5, down. Okay, taller by 2. There you go. So we'll call that taller. I've never used that term. Taller by 2. But what it does is it takes that point, and if we look at these points, so here's our first point, here's our next point, 1, 1. So if we go over 1, notice it went over 1 is here, and it went, instead of 1, 1, it went up 2. So 1, 2. So over 1, up 2, instead of right 1, up 1. So that's what it's talking about when it's taller by 2. Okay, so interesting. So the parent, oh, this is what we're starting with. So it's already shifted. This is a V, absolute value. So our vertex is already shifted. It shifted up 3. But what is it going to do from there? And this will be interesting to see if they take this as my starting. Because if we go down to 6, well, that's a change. That means this went down 9. So let's see if down 9 is our answer. Yeah, good. Okay, good. So it did take this as the parent. So let's take a peek on Desmos and see what that looks like. So that looks like the absolute value of x plus 3. And our new one is going to be, sorry, equals. Nope, sorry, that 3 is outside of the absolute value. So you see how it shifted up 3. And now my new one is 1/2 the absolute value of x. This one is inside. So you know that that's going to move it left and right, minus 6. So we see that it went down 9 because this is the outside still. This still deals with my up and down. And since this was already up 3, and then it went down 6, so we went down total of 9. This is my interior, and we're going to go with the opposite. So that's my left, right, but it's going to be opposite. So I'm going to go -2 is going to be the opposite of +2, so right 2. And then this is going to do it by 1/2, and you saw that it got wider. So let's see what that was. So if we went from one point right here to this, so that's up, right 1, up 1. So if we go over 1, how many do we, oh, we only go over 1/2. So we're going to go, it's going to get wider. So it stretches vertically, and it's going to be a, so how would we do that? How would we explain that? So it's going to, what did it say? What did we say in the problem before? We said that it went taller by 2. It went shorter by 1/2. Is that what they want? Oh yeah, shorter by 1/2. Let's go. Shorter by 1/2. Yeah, that's typically not how you're going to describe it. They don't teach you that in Algebra 2 and pre-calc. You'll see these types of of things. Okay, so first thing, this is our original. Some of the things that we have to notice, this is going to be upside down, and we know that that's going to be taller by 2, but it's going to be upside down, so it kind of looks like this. So this is going to tell me what it's going to go up 7, and then inside means it's going to go right 1, and then now, okay, so what does it do? It just flips it. It's not going to get any taller or shorter because it's the same unit. This negative just tells me that it's upside down. So it's going to flip on the x-axis, and then it's going to go right 1 up 7. Let's see if that says that. Reflect over x, right 1 up 7. Let's go. Love it. And that's it. Nice. All right, that one definitely, you might want to take a peek at some of my videos. I've definitely done some stuff on this, on the shifts of, but this is definitely an Algebra 2 concept. But take some time and learn how to see what the shifts are. All right, good luck.